Alright, so in this video, we're going to be doing an introduction to what a logarithm is. I know this says logs. Logs is short for logarithms. Alright, so what is a logarithm? A logarithm is an inverse of an exponential function. So we've been talking about exponential functions, which exponential function, for those of us that may have been asleep the past couple weeks, an exponential function just means a function where the variable or the input to the equation is x. The variable is the exponent. A logarithm is the inverse of an exponent. It's mainly going to be used when we're solving exponential equations. This basically allows us to get the variable x out of the exponent. The way it works is we have given b to the x equals a, so given an exponential equation, a logarithm is defined as log base b of a equals x. All that means is they are color-coded for a reason. So a log with base b, the b is the base of the log and the base of the exponent. That's why it's a b. The x is an exponent in an exponential equation, but it's what the logarithm is equal to. The a value is what the exponential equation is equal to, but is actually the input of a logarithm, and I'll show you why. What I have color-coded in the second bullet is technically a shortcut that you can memorize. If you want to memorize the format, you can. I try to avoid memorization and try to just show you why the math works the way it does. We're going to be solving it next week, and when we're solving it, you're not always going to be able to just rewrite it in the other form. So as opposed to asking you to memorize what I have in color, I'm going to show you why the math works out. So the examples here, what I mean by examples is it's currently in exponential form, and I'm going to write it in logarithmic form. And then in the second example, it's currently in log form, and I'm going to write it in exponential. So how this is going to work, or the way this is going to work, is in order to write it in logarithmic form, we need to log base both sides. And the base of the logarithm should match the base of the exponent. So, in the first example, the exponent has a base of 2. It's 2 to the 4th power. So again, the exponent has a base of 2. Therefore, I will log base 2 both sides. But if you notice, I'm not changing 2 to the 4th or 16. Nothing changed here, except that I put a logarithm with base 2 on both sides. So I have log base 2 of 2 to the 4th equals log base 2 of 16. If you want, I can put these in parentheses to show you that those inputs or those parentheses are the same. All right, so magic is about to happen. So log base 2 of 2, are you ready? They're equal to 1. And I'm not going to get into every log property in the world why this happens yet. But log base 2 of 2 disappears. It cancels out. It equals 1. So what this turns into is 4 equals log base 2 of 16. And that's it. So in order to get to logarithmic form, you log base both sides to match the base of the exponent. And I have more examples. I'll go much faster on the next slide. Okay, so the second one is already in log form, and I want to put it in exponential form. So in order to do that, I'm going to do the exact opposite of what I just said. I'm going to exponentiate both sides, and the base of that exponent is going to be the base of the log. So in this example, I have log base 2 of 8 equals 3. I am going to raise both sides to have an exponent base of 2. And I know this looks weird, but in algebra, we can basically do whatever we want as long as I do it to both sides. The reason this is helpful is similar to the first example where log base 2 of 2 canceled out and just left me with that 4. This 2 log base 2 also cancels out. So if a log base matches its input, or if an exponential base matches the base of a log, they go away. So the second one is just 8 equals 2 to the third. And when you're writing in exponential form, you can quickly check yourself because 2 to the third is 8. So that statement has to be true or you messed up. But to get rid of log base 2, we exponentiate or raise both sides as exponents, and the base of that exponent is 2. But see, I'm not changing anything. I just put a base exponent of 2 on both sides. Okay, so there's 3 examples here. So we're going to evaluate. This is the majority of what I'm going to ask you to do. But so when we're evaluating, we want to know, what does log base 3 of 9 equal? So we're just going to say it equals x, because I don't actually know what it equals. So we're going to raise both sides to an exponent of 3. A base exponent, sorry. We're going to have a base of an exponent of 3 of both sides because the log base is 3. The base of the exponent is the base of the log. That's how this works. So these go away, and I'm left with 9 equals 3 to the x. And then now we're going to exercise a little bit of common sense, and we have to know 3 to what power is 9. And hopefully we know that 3 to the second power is 9. So x equals 2. So when I say evaluate, I want the number. So log base 3 of 9 is equal to 2. So the second one, we're going to do the same thing. We're going to do equals x. And the base of the log here is 2. So the exponent base I'm going to choose is 2. And just like all the others, 2 and log 2 cancel out. So I'm left with 16 equals 2 to the x. So now I have to sit here and think, well, 2 to what power gives me 16? So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power equals 16. Last but not least, I have log base 16 of 1/4. So we're just going to put that equal to x. The base of the log is 16. So the base of the exponent for both sides is going to be 16. And this is about as tricky as I can get. Just heads up. So we have 1/4 equals 16 to the x. And this one we may not be able to kind of common sense our way through because it's weird. So this one we're going to have to solve with the equating bases. That's what we just took a quiz over. So I'm going to choose both sides to have a base of 4. Then we have to remember that 1/4 means 4 to the negative first power. Because 4 to the positive first power is 4, but if I want 1/4, that means my exponent needs to be negative. So 4 to the negative first power is 1/4. Then I'm going to change 16 to have a base of 4. And I know that 16 is 4 squared. So I change the left side to be 4 to the negative first, because 4 to the negative first power is 1/4. I changed the right side. I rewrote 16 as 4 squared. And this is just the equating bases that we did Friday and Monday. So 4 to the negative first equals 4 to the 2x. Once I have the same base, I can set my exponents equal to each other. And I see, I'll write out of that dosary stuff. X equals negative 1/2. I will say there's good news. We will have our calculator for this on the test. And if you memorize the rewriting, it may seem easier now, but I promise you solving next week, it's going to be much easier on you if you focus on rewriting like this, even though it's technically a little bit more work than what some of your friends in other classes may be doing. So when you're doing this, you pick the base of the exponent should match the base of the log. So in the first example, it was log base 3, so the base of my exponent on both sides was 3. On the second one, I had log base 2, so the base of my exponent on both sides was 2. On the third one, the base of the log was 16, so the base of the exponent on both sides was 16. Most of your problems are going to look like the first and second, where they're very straightforward. I'm just showing you the third, cough, cough, just in case we have one complicated one on a quiz or future test.